Looking at this question using Mathematica, first thing was finding the first and second derivatives. Now in Mathematica it's actually quite easy to do derivatives. I'll add a line here so you can see. So basically you use the D, capital D, square bracket, and then you put in the function. So for example here it was the exponential, I'll just do it like that. So exponential of x times 10 minus x times x. Now when you put this function in, you have to tell it what to differentiate with respect to. So that's a comma x because it's like d dx, you know. And then evaluate, and you can see that's your derivative right there. So what I've done here, just to make it a bit easier, I put two derivatives here. This is the first derivative. You can see there's only a comma x here because it's a d dx. This one has two x's, a comma x, comma x. It's because we're going to differentiate two times. So however many times you want to differentiate, you just put more comma x's in. So I've put these in a little set here because when I find their answers, which I've done, I'm now going to plot them. So I'm going to plot them because it says sketch the graphs on one set of axes. So I'm actually going to sketch, actually I only need to sketch the original function, so I'll sketch just the second derivative. So I'm going to put these in a set. I'll put the original function in, which is f, and the second derivative. So they're in little brackets. Oop, looks like that. So that's our two graphs, f and its second derivative. Here we had the first derivative and the second derivative, which was answers to part A. This is the answer to part B. Then part C, it says find the value for which the gradient of the graph is a maximum. Now this happens when the point of inflection is 0. So, not the point of inflection, the second derivative is 0. So at the point of inflection. So what we've done, or what I've done here, is taken the second derivative, comma x, and let that equal 0, and then solved it. You can see we've got two values here. Now those two values are a little bit hard to work with, so I've just done an n with the percentage sign to work on the thing above. So you can see that there's 2 points here, so we need to use the one that is going to make sense on the graph, which is this one. So it's this one here, 3 times 1 plus root 3. So that's the value for x, where your second derivative is 0, it's a point of inflection, but it will correspond to a point of, on your point of inflection graph, second derivative graph at 0. So the point of inflection would be here, and that's where you've got that concavity changing from positive to negative, so there's our minimum gradient is there. So it happens at this x value. So the answers for A, B and C are these two answers for A, this graph for B, and then this answer here for C.